Hello and welcome to this unit on SQLite 3. First of all, we're going to answer a very important question. What is SQLite 3? Well, SQLite is a self-contained SQL engine. We can pronounce this SQL, that's the preferred way, or some people pronounce it SQL. But at any rate, it's a self-contained SQL engine. SQL is a relational database management system. It's a language, actually it's two different languages rolled into one that help us maintain and define databases and their structure, and also run queries against those databases. SQLite requires no separate server to run, so it's very lightweight and it can be used on any platform at all, but its size, because it requires no external server, and portability make it attractive for use on mobile devices. And iPhone, iPad, actually any of the Apple mobile devices all come with a SQLite library that we can install to support SQLite on the devices. Most of our SQL functionality is supported by SQLite 3. And we can find full details on the web at www.sqlite.org, including the documentation that you'll need to take a look at the query language itself and how it's written if you don't have any experience at all with SQL. So what is SQL itself? As I already said, it's a structured language that we use to define and interact with data in databases. The data in a database is arranged in tables, and each table contains columns which define the name and the type of each record, of each data piece, each field in the record. And then when we add a record to a set of columns in a table, this adds a row to a table. So the structure of a table is in columns and rows. SQL itself contains two kinds of syntaxes. It contains a syntax to define new tables and other structures in SQL, queries and views and things like that. And this is sometimes called DDL. This is the data definition language, if you want to be a little bit picky about separating these types of languages. However, the DDL and the actual query language are very similar. The syntax, though, to select, insert, delete, update rows within tables is called SQL, and that's where the name SQL comes from. And SQL stands for Structured Query Language. A query being a question that we ask the data, and we get a result set back, an answer back. And the actual query type here that we're talking about is called the select query, which is where this query language piece comes from. So how do we create an SQL database? Well, there are a lot of tools available to do this, but I just use the command line utility that we get with Macs with Xcode, and the command line utility is SQLite 3, followed by the name of the database that we want to create, if we're making a new one, or edit. And that database name should really end with a .SQL. The extension should be SQL. It could really be anything or nothing at all, but just to make sure that we understand that the file we're working with here is as an SQL file, we should extend it with .SQL. And when we do this, when we issue this command at the prompt, we get this text back, SQLite version 376 in this case. Enter .help for instructions, and then enter SQL statements terminated with a semicolon. If the database doesn't already exist, it's going to be created with no tables. The utility will save this database wherever we run the utility. So it'll save it in your folder structure, and it saves it in one file. And this is really nice because we can pick up that file, move it to our application bundle, and then write some code within the bundle or within the application itself to move it to the documents directory so that it's read-write. If the table does already exist, the utility will just open the table. Now, very importantly, you have to have permissions to the folder that, or to the directory, you have to have read-write permission in order for this database to be created there. We can show all of our meta commands, all commands about commands, using the .help command. And .help gets you started, but it doesn't tell you anything about SQL syntax itself. For that, you're going to need to review SQL by going online. www.sqlite.org will give you a full list of the working SQL and DDL syntax. To exit the utility, just type .quit at the prompt. Now, SQL commands need to be terminated with a semicolon. In other words, if it's an SQL command, terminate it with a semicolon, but a dot command does not get terminated by a semicolon. So how do we create a table? Once we're in the utility, we use the syntax create table, literally, and then the name of the table, and then followed by, in parentheses, our column definitions. And each column definition is separated by a comma. And finally, after the closing paren, this is SQL syntax. It must be terminated by a semicolon. So the table name is the name that you give the table. This can be anything at all. SQL is case insensitive. It does not have to be capital create table. When you're typing up a database very quickly, I usually just do them all lowercase. The things do get converted, though, when you look at the schema of a table, and that's very nice. They get case converted for you. But for consistency's sake, I like to make my table names begin with a capital letter and to be in camel case. That's up to you. But that's my sort of syntax rule, is that table names themselves start with the capital letter, whereas field names within tables, column names, start with the lowercase label. So now column defs is the name and the type of the column that you're defining, or the field that you're defining for the record. Now, optionally, you can also put the type of the key. Usually this is either primary key or foreign key. You can also stipulate that this column be not null. In other words, it will not accept a null into the column when we write data into a row. You can also say that the column is going to be auto-increment. Now, the key type and auto-increment, if it's a primary key, and if it's an integer type, it's going to be auto-increment. So these three fields that are optional kind of have some dependencies associated with them that we'll talk about in the demos. It's especially important, though, for each row of a table, for each table to have an ID column or some type of column that is globally unique within that table. And we usually define that to be name ID, type, integer, primary key, not null, and auto-increment. And that way, we get an integer primary key that is guaranteed to be unique. And we'll look at that in the demos as well. Every column def and every field within the column is separated by a comma. So we enclose all of our column defs in parentheses, and then the entire statement is terminated by a semicolon. So now, there are some things that we can do within the DDL to work with tables. First of all, let's say we make a mistake within the definition of a table. To remove the whole table from a database, we issue the command drop table with the table name and then a semicolon. And this doesn't ask you if you're sure you want to do this. This just drops the table. It's gone. In some other versions of SQL, you can also issue a drop database. Since we're working with one file at a time with SQLite, in order to, quote, drop the database, we just exit out of the utility itself and then delete the file. There's only one file that houses the entire database. If we want to see all the tables in the database, their names, we can just type .tables, and this will show us all the tables within a database. We can see the create statement for a table by typing .schema and then the name of that table. And if we type .schema without a table name, we can show the create statements for all of our tables within the database. So this is a brief overview of working with SQLite 3, and we're going to get started with a couple of demos. The first one, we're going to create a table, and we're going to create two tables within a database that we'll use as the new model of our parts room program. And then in the second demo, we'll show how to get that database into our application and how to move it into the documents directory if it's not already there. Thank you very much.